In this particular video, we'll be talking about chlorofluorocarbons, CFCs in short, and the ozone layer. How does CFCs, chlorofluorocarbon, deplete the ozone layer? So, this is how it does it. But first, before we proceed, you have to understand something called the ultraviolet rays. Ultraviolet rays comes from the sun. And the ultraviolet rays comes from the sun and is caused by the radiation from the sun. We get sunlight by radiation. Radiation means there's a source and the heat energy and light energy comes from that source, like the sun. The heat energy comes from the sun and then causes ultraviolet rays. Now, the earth is constantly bombarded by ultraviolet rays, and the ultraviolet rays is risky because it can damage DNA, and once DNA is damaged, it can also lead to skin cancer. So, how have we been protecting ourselves from these ultraviolet rays? Because if ultraviolet rays is always coming from the sun, how have we protected ourselves? We have protected ourselves by the ozone, the O3, the ozone layer. And the ozone layer, this is where I want you to take note of. The ozone layer is an allotrope of oxygen. Oxygen is either diatomic or triatomic. Diatomic is the oxygen we breathe in, triatomic is the ozone layer. And the function of the ozone layer is to absorb harmful UV radiation before it reaches the earth. So what is coming into the earth is actual heat energy and not the radiation of ultraviolet rays. So where is the ozone layer? The ozone layer is located in the stratosphere. Keep this in mind. The layer that has the most amount or the most quantity or volume of ozone is the stratosphere. And the stratosphere is just one level above the earth. We have the troposphere. The troposphere is where helicopters, aeroplane, where they fly. The stratosphere is the level that protects the earth. Why? Because it has the most volume of the ozone layer. So, how does the ozone layer, how is this formed? When UV radiation comes, it breaks the double bond of oxygen. So normally, oxygen, you have O2. So it breaks the double bond of oxygen where you have two O's, like this one here and this one here. So this first O combines with the double bond of oxygen and forms a triple bond to form the ozone layer. So what happens is the UV radiation is actually useful in some sense. It's useful in breaking down the oxygen in the air we breathe and combine it with a double bond of oxygen to form a triple bond of ozone. So without the UV radiation, we cannot have the ozone. But there is a problem. This process has to be balanced. This process has to be balanced. If there is too much ozone, it means that we don't have enough oxygen to breathe in. And if there is too much oxygen, it means that we don't have enough ozone layer to protect us from the ultraviolet rays of the sun. And how does this happen? Through chlorofluorocarbons. And chlorofluorocarbons, instead of the ultraviolet rays breaking oxygen and combining, remember ultraviolet rays breaks O2 to OO and then combines it with O2. This combines with this to give the ozone layer. What happens to chlorofluorocarbon is that it dissociates this ozone layer back again to the original composition, oxygen as a monomolecule and oxygen for breathing. And so this free radical or free oxygen combines with carbon monoxide to form carbon dioxide. So as the ozone layer is broken down, which causes the depletion of the ozone layer, the next thing that happens again is global warming. So you see that they work hand in hand together. And where do we get chlorofluorocarbons? This is a type of haloalkane, and they are relatively non-toxic until when released into the environment. In the past, we used them in refrigerants, in freezers, refrigerator, in aerosols, and from the major source of freon. We use them in refrigerator and all of those stuff. So how does chlorofluorocarbon dissociate the ozone? I have explained this previously, what happens is that once UV radiation shines, chlorofluorocarbon is 2 chlorine, 1 carbon, and 1 fluorine. It dissociates it. It causes a radical chlorine to be free. The radical chlorine can be free, and so the radical chlorine combines with the ozone. So the radical chlorine plus O3 will give you ClO, chlorine monoxide, and oxygen. And so the ozone layer is already depleted. And so once that happens, the next thing that happens is that the cycle begins itself. That free radical combines, that chlorine monoxide, and we have oxygen. It combines again with a free radical of oxygen and then frees the chlorine. The chlorine is freed for another continuous cycle of attacking the ozone layer, being free, attacking the ozone layer, being free. And what happens is, as this process happens, there is a chain reaction. The chain reaction, so the chlorine radical is just a catalyst. Remember I said a catalyst is an example of something of an element that is used to speed up a chemical reaction without being used itself. It is not used up. So the free chlorine that has been separated by the UV radiation acts basically as a radical. It just keeps on happening, and slowly the ozone layer found in the stratosphere is completely depleted. And then UV radiation from the sun has a direct access into the earth and affecting us. So I want you to test yourself with these questions. Look at these questions. Let us look at these questions. Which atmosphere layer contains the highest concentration of ozone? Remember I said that the layer that contains the highest level of ozone is the stratosphere. Why? Come back to our drawing or our slide. We have this here, this bit. This way. That is the one that has the highest level of ozone. Next, which of the following pollutants will lead to depletion of the ozone layer? Now, carbon monoxide does not lead to depletion of the ozone layer. Hydrogen sulfide or sulfur dioxide does not lead to depletion of the ozone layer. It is carbon dioxide that leads to the depletion of the ozone layer, and chlorofluorocarbon. What carbon monoxide does is that it causes poisoning. It causes carbon monoxide poisoning. The gas, and the reason why the oxides of carbon are a problem is that if carbon monoxide combines with oxygen, it forms carbon dioxide and a free radical oxygen. That free radical oxygen that is produced is what combines with chlorine here. In this process, is what combines with chlorine here, and once it combines with chlorine, it then continues the cycle. So the answer here is that which of the pollutants will lead to the reduction of the ozone layer is chlorofluorocarbon. Let's look at another question. Chlorine gas is majorly used in the production of what? It is chlorofluorocarbon. Remember we said in the composition of chlorofluorocarbon here, where we said chlorofluorocarbon is 2 atoms of chlorine combined with 1 carbon combined with 1 fluorine. That is your answer. So we have come to the end of air generally. At the end of this video, go to your student portal and answer questions on air.